In this video, we're going to look at some relations and decide if each of them is a function or not. So to start with, let's put up some definitions. A relation is a relationship that pairs input values with output values. And a function is a special kind of relation. It's a mathematical relationship in which each input value is paired with exactly one output value. So a function is like a special kind of relation. So we're going to look at some different relations and see if they're functions. Each of the relations we will be looking at is going to be in the form of an XY table. So all of them definitely, meet the definition of a relation. I've got some inputs, I've got some outputs, they're paired up. But to be a function, I have to go through and I have to check, does each input have exactly one output? And you may want to pause this video as you go along each time I put one of these up and make your own decision before you hear, so you can kind of check your intuition and see if you're right. So for this first one, well, let's go through and look. If I put in a 1, is it predictable? Yeah, there's only one place that there's a 1 and it gives me a 5. 2, yeah, that's predictable. I get a 4 every time. What about 3? Predictable? Yeah, I get a 3. 4, I get a 2. 5, I get a 1. This one's very predictable. Each input has exactly one output. So this one is a function. This can go in my yes, a function little stack over here that I'm going to make. Yes, this one is a function. What about this one? Go ahead and pause the video and develop your own idea about whether or not this relation counts as a function. Okay, so this one, let's go through it. If I put in a 1, is it consistent? Yes, it gives me a 0. There's nothing else. I look over here, there's nothing else that could happen if I put in a 1. It's definitely going to give me a 0 out. What about 2? Well, I put in a 2, it gives me a 0. This is a super boring situation here. But it's consistent. Every time I put in a 2, it's going to give me a 0. It's never going to give me anything else. 3, 4, 5. It's consistent. Each input is paired with exactly one output. Some of them have the same output, but that's okay. That's not part of the rule of being a function. So this one also goes in our yes stack. What about this one? Go ahead and pause the video and develop an opinion. Use the definition. Is this a function? It looks very similar to B. Super similar. This one, okay, let's go through it. I put in 0, it gives me 5. So far, so good. I put in 0, it gives me 4, but you just said 0 was 5. What even? Now I put in 0, I get out a 3? What are they even doing here? This is not a function because sometimes when I put in a 0, it gives me a 5. Sometimes it gives me a 2. It's like they can't make up their minds what they're doing with zeros. It could go to lots of different stuff. So this one is not a function because each input needs to have only one possible output. This has 5 possible outputs for the same input. So that relation, while it's a valid relation, is not a function. What about this one? Again, pause the video and develop an opinion. Is this a relation? Oh, I mean, definitely it's a relation. Is this relation a function? Yeah, it is. Each input has exactly one output. It's boring, but functions are allowed to be boring. about this one? Pause the video, take a look, and decide if this is a function. Okay, well this one starts out strong. 1 goes to 5, works so far. 2 goes to 4, still fine. 3 goes to 3, yeah, okay, so this must work. 2 goes to 2, what? You said 2 goes to 4. Now you're saying 2 goes to 2? 1 goes to 1, 1 goes to 5. What? No. So this one started out so well, but it's just not a function. Some of the inputs map to more than one output. Just not gonna work. What about this one? Pause the video and take a look. So this one, it's like they're just not very organized over here. Let's see what we can figure out. So if I have a 1, it goes to 5. So far, so good. If I have a 3, it goes to 4. Okay. If I have a 4, it goes to 3. Okay, so those two just kind of swap with each other. Whatevs. 2 goes to 2. Why didn't you put this up here? Could you, like, plan? And 5 goes to 1. So this is fine. I mean, it's disorganized. If I wanted to do something with this information, I'd probably rewrite it so that it was in order. But that's okay. Functions can be a little disorganized. Each input still maps to only one output. Now, let's take a look at our next relation. So pause the video, take a look at this, and decide, is this relation a function? Okay. 1 goes to 5. We're doing well so far. 2 goes to 4. Yeah, okay. 3 goes to 3. Okay, that's fine. 2 goes to 4. That's the second time you've told me something about 2. But it still goes to 4. So that's fine. I mean, it's not necessary. I could cross this right out and it wouldn't do me any harm. But it's still a function because it's going the same place. That input is again going to that output. And same with 1 and 5. So these two, I mean, I could just cross them out. They're not important. They don't give me any new information. But it's still a function because each input goes to one output. It's just disorganized, and that's okay. You might clean it up a little bit before using it. Take a look at this one. Go ahead and pause the video and take as much time as you need to look at this one. So this one, 1 goes to -4. That's fine. It can go to negative numbers. None of my other examples have been negative, but that's okay. 2 goes to 23. I'm not really seeing a pattern here, but 3 goes to 3, 4 goes to 2, and 5 goes to pi. So this is a function. I can't predict what 6 would go to. A lot of these I could predict what 6 would go to. This one I can't, but that's okay. It's still a function, even though I don't know what 0 would be or what 6 would be. As long as I'm only dealing with these 5 inputs, as long as I'm dealing with that restricted set of inputs, that's fine. I know what each output goes to, and each input goes to only one output. So that's a function. And last but certainly not least, is this a function? Go ahead, pause the video, and make up your mind. Well, does each input only go to one output? 1 goes to star. There's nothing else 1 ever goes to. It goes to star. I mean, we've got this whole Lucky Charms situation over here, but 1 goes to star every time. 2 always goes to heart. So, I mean, fine. I don't know what to do with it after it's done it, but fine, I know what to do. 3 goes to smiley face. Okay. 4 goes to, looks kind of like a cloud monster or something. And 5 goes to a stick figure. So, I mean, it's a function that I'm not really sure what to do with the outputs for, but I know what to do for each input. I know what to get out of it. So this is a function. So let's take a look at our entire collection of examples and non-examples. So I will just scoot down the paper and we will look at all of our functions. Start out with our first example was a function. Our second example was a function. Our fourth example was a function. And here are the rest of our functions now that we've got sorted. So here are a lot of examples of things that can be functions. Sometimes they're very predictable, and I have a really good guess what 6 would be. In this case, I'm going to guess 6 goes to 0. In this case, I'm going to guess 6 goes to 0. In this case, I'm going to guess 6 goes to 6. Some of them may be a little harder to figure out. That's okay. Like this one, I have no idea. 6 could be anything, it's not even clear. This one, I have no idea. But they're all functions because for each input, there's exactly one output. And we only had 2 in our no pile. Both of these had a situation where sometimes the same input goes to different outputs, and that's what makes it not a function. But all of these are.